Okay, it's Professor E. Let's look at these practice problems for set theory. Problem number 1 says D is the set of whole numbers less than 3. So first thing you got to think about, what does that mean? That means less than 3 and whole numbers are 0 and greater, 1, 0, 1, 2, and it says less than 3. So it can't include 3, and it can't include fractions, cannot include decimals, and it can't go below 0 because these are whole numbers. So we would simply say that D equals, and then we do one of these brackets, not parentheses, but brackets, 0, 1, and 2. That's roster form, and then set builder notation, the specific form. We write X, this vertical line, which means such that X is a whole number comma, and X is less than 3 with the brackets at the end. So again, it's read X such that X is a whole number and X is less than 3. And that's number 1. Okay, number 2, in set builder notation. Again, so remember, it has to be in this format like they have it in our answers. First thing we have to do is solve the inequality. So it's just a little review. 3x plus 10 is greater than or equal to 4. Subtract 10 for both sides. And I get 3x is greater than or equal to negative 6. Divide both sides by 3. And I get x is greater than or equal to negative 2. So in set builder notation, we're going to write X, vertical line, such that X is greater than or equal to negative 2. And that was choice A, and that's all there is to it. Okay, number 3, it says, suppose U, which is the universal set, contains these elements here. Calls it the universal set, and T is the set negative 10, negative 6, and 0. What is the complement of T? Hopefully from the notes and from the videos you understood that the complement is what's in the universal set that's not already included in T. That's the complement of T. So we just look at what's in T and we take it out of the universal set, and that'll give us our complement. So we see that negative 10's in there, so we'll get rid of that. Negative 6 and 0. So I'm left with negative 2, 3, and 5. So the complement of set T is the elements negative 2, 3, and 5, which is choice A. Okay, number 4. You have 2 boxes of colored pens. The first box contains a red, make sure we get all these right, a red pen, a blue pen, and green pen. The second box contains a yellow pen, a red pen, and a black pen. What is a set that represents all the pens? Well, hopefully that isn't going to give us too much trouble, because all we have to do is list all the pens. So we have a red pen, a blue pen, a green pen, yellow pen, and a black pen. Notice in C they listed red pen twice. You never list the same element in a set 2 times when you're answering your question here. So the set that represents all the pens is simply the union of the 2, which is all the pens, which is red, blue, green, yellow, and black. Okay, number 5. It tells us 3 different sets. It gives us set X, set Y, and set Z. And we don't really care about Z because it just wants to know in this example, what is X intersection Y? Intersection Y. So intersection, what they have in common. So first let's figure out what X is. It says X such that x is a whole number less than 15. So we might just want to list those. 15, less than 15. So we don't want 15. We want 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. Remember to keep 0 in there. So that's x in roster form. So it wants the intersection of that with y, and it says y is multiples of 3. So y are multiples of 3, and in roster form that'd be 0, 3, 6, 9, 12, 15, and I could go on and on, but I don't need to because I know this set starts at the highest number is 14. So I just want the intersection. What do these have in common? Well, they have the 0, 3, 6, 9, and 12. So I would have answer A. 0, 3, 6, 9, and 12. And that's it for number 5. So the next 5 will be on a separate YouTube video. So I'm going to pause this one.